Hi everyone. So here we are going to present a small presentation on the deployment of a Go application using AWS ECS, which is Elastic Container Service, ECR, Elastic Container Registry, and Fargate. We are going to deploy a small application in Go. Uh, there is a small overview of the application, which we have developed in Go language. It's a static web application. Here we have used a static HTML template which is service to users, providing a good user interface. The front end has an overview like of a project. It's like a project hub which has projects and contact details and ensuring, which has a good engaging user experience. And in the backend, we have used a RESTful API, which is developed in Go language, which is capable of handling incoming HTTP request, and also has a high performance and simplicity and extensibility. So it is built to run efficiently on a containerization platform, and also it's like compatible for Docker, and which is portable to run different run on different runtime environments. And also the main requirements of this project or application is like it should be scalable in terms of huge traffic to handle traffic load, and also it should be highly available without any downtime, so that there's no interruption in the service to the users. And also the most important thing is security. We should have security for the users and the application. So then we are using two services like IAM, which is identity and access management, and also VPC, which is virtual private cloud, for security. And the main platform where we are deploying this application is containers, ECS, ECR. So the basis for these services are containerization. So here we'll deploy the application into a package and make deploys it to a container, and which is remotely stored on the cloud in Elastic Container Registry. So these are the main requirements of the application deployment. So here we are choosing AWS as the cloud provider. Uh, in AWS, the main services for this containerization uh, and container services are Elastic Container Registry, which is used for storing the Docker image and in the cloud, and Fargate, which is a service for server management without really bothering about the infrastructure. So it's like it simplifies the deployment and scaling. So and also we are employing pay-as-you-go model for optimizing the cost. So and also, as we said earlier, for the security, which is main important thing here, we are using IAM, Identity Access Management, and CloudWatch for monitoring in terms of any alarms, or if here we did not employ alarms, but in real time we can do it so that if there is any uh, unusual or unauthorized service access going on into the application, we can use alarms so that we will be alert for the threats. So these are the things. So here the deployment architecture, this is just a high level overview of what we are deploying into the cloud. So first we have developed the code in VS Code, like in the local desktop. So then we created a Docker file to deploy that, to create an image from that Go main.go file. So after the Docker image is created, we have tested the Docker image in the local, which is we are uh, successfully able to view the static web page. And then now to push it to the cloud, we are using ECR. So which is Elastic Container Registry, where we'll create a repository and push that to the ECR. And after that, we'll push it to ECR, Elastic Container Service, which will manage the containers, and which is that after creating a task, we'll push it to that place where it's stored in a container. So here the application is executable on the container side. So we can see that on the browser, to the application is accessible successfully. So here the architecture components, like we have seen earlier in the diagram, the components are like Elastic Container Registry which stores the Docker images of the application, and services, Elastic Container Service, after deploying the application into the containers, it manages the containers and tasks in the cloud. So Fargate, which is a serverless environment, which where we don't have to bother about the servers and the infrastructure behind the application which is running live. And also application load balancer, so which is used to distribute the traffic. VPC, as we all know, like is a virtual private cloud from the AWS environment, which is a default. There is a default VPC running behind our application, like which is enclosed in VPC, which is very secure for us. So CloudWatch, as usually, it monitors the logs and performance metrics of the ECS tasks and application. It ensures that the applications are healthy, so that when the user sends a request, they will deliver the correct response. So the next will be told by my friend.
Hi, we are coming to deployment workflow. First of all, containerization is like we use for Go application as packaged into Docker image. We build a Docker image in that, and we upload Docker images into ECR for storage and version control. Next, we coming to ECR cluster setup. For ECS task definition was created and specifying Docker images which have pushed into ECR and require resources like CPU and memory. And if we after configuration, we launch Fargate tasks, and we also uses service management. ECS service has configured to run multiple tasks with the auto scaling enable for CPU and memory everything. If next we are coming to creation of ECR and AWS cloud. Here we can see which is the repository name of group F, and it shows that ECR how we create, and we have pushed images on in this. Next we come into the photo of cluster ECS, how we create. We update all the names for as assignment group F and infrastructure and all required configurations. Next coming into ECR, it shows like task in ECR like public IP address which were accessible for application access. With this public IP, we can access web page. Next coming into the deployment, this shows like successful execution of a command like curl command to access deployed application using public IP on port 80 which we exposed on Docker image. Like it confirms like application is successful by showing 200 OK HTTP status code. Next best practice will be still by my friend.
So when it comes to the best practices, we will be discussing about the scalability, security, and monitoring. When it comes to scalability, we will be mostly considering the auto scaling. We will be automatically adjust resources based on traffic or utilization, ensuring your system can handle varying workloads efficiently. We use AWS Fargate for serverless containerization to automatically manage scaling without needing to manage servers, and we deploy EKS tasks across availability zones to enhance the fault tolerance and minimize the impact of potential failures. When it comes to security, we use IAM roles for task execution to avoid hard coding credentials in containers, improving security. We ensure elastic container registry to prevent unauthorized access, and we create virtual private clouds and security groups to control network access and associate your EKS tasks. And we will be giving the least privileges, which is like we will be giving permissions to the set of users, whoever can access the resources. And when it comes to monitoring, we leverage Amazon CloudWatch for real-time monitoring of application performance and health. We set up alarms to detect anomalous or miscellaneous performance issues early, allowing for proactive resolution. And when it comes to cost optimization, we choose appropriate CPU and memory settings for ECS tasks to avoid over-provisioning and reducing unnecessary costs. We use AWS Cost Explorer to analyze usage patterns and optimize resource allocations, automate the shutdown of unused resources during non-peak hours with AWS Lambda or AWS Scheduler to save the cost. So when it comes to the challenges and solutions, here's the challenges that we have encountered while setting up AWS environment IAM roles and ECS clusters. So we followed the AWS documentation to set up the process of setting resources such as IAM roles, ECR repositories, and ECS clusters. And the second challenge is authentication issues while pushing the images to ECR. So while pushing the images, we have necessary IAM permissions to interact with ECR repository. And the third challenge is Docker images fail to push due to incorrect tagging. The solution for this is to double check the Docker image and correctly tag with appropriate ECR repositories to name the avoid push failures. Thank you.